Welcome to the Femap 10.3 What's New video series. In this video we'll be looking at new Femap support for Nastran aeroelastic analysis capabilities. The Aeroelasticity capability allows you to investigate the effect of an airstream on a structure. Aeroelasticity will calculate the aerodynamic loads and apply them to the structural model, and can simulate the effects of both static loading and aerodynamic flutter. In this example of a forward-swept wing aircraft model, the structural model is very simple and comprises a beam structure with mass elements representing the main components of the aircraft. The aerodynamic model comprises panels that represent the lifting surfaces and bodies, splines that interpolate between aerodynamic and structural grid points, and control surfaces. Looking at the properties first of all, it's possible to define aero panels and bodies. The body property, for example, is where the cross-section data is defined, and also the surrounding interference tube via the theta array that represents interference elements between the body and the lifting surfaces. Let's look at one of the aero panels now and select the first, which happens to be the starboard canard. Here the dimensions of the panel are specified, as well as the aero mesh. Splines are also needed to interpolate between the aerodynamic surfaces and the structural grid points in the model, which are defined by a group. Control surfaces can be defined which reference local coordinate systems that represent the hinge line. Control surfaces can also be activated in the analysis trim settings. With the modeling definitions complete, let's look at the analysis setup. In the Analysis Manager, we can set up the basic parameters for static aeroelasticity or dynamic flutter, as well as trim parameters such as pitch, roll, and control surfaces for statics, or flutter parameters for a flutter analysis. The intention of the aeroelastic analysis is to determine the loading due to aerodynamic effects on the model panels and bodies. These loads are transferred to the structural model, which simply comprises beam and mass elements in this case. So we can switch off the aero model entities and view the results as beam diagrams showing stress contours. So aeroelastic analysis can be performed to determine aerodynamic loading on any structure that experiences the effects of an airstream. To find out more, visit us at siemens.com/plm/femap or call your local channel partner.